Okay, so this is going to be part 2, and we're going to create a player character or box that moves around as in a top-down game, and we're going to give it some physics, so it'll move quite nicely. It won't move instantly, it'll have a nice smooth movement to it. So here we are with all the things where we left it up in tutorial 1 with the setup, and we can just start putting a player into our scene. So we've got our splash screen. I press spacebar, takes us into our scene. So for now, we're going to take this out because this is where we just rendered some text in the scene. We just leave it filled as red. I've changed my colors here, so it was really bright before. It's a vivid red, green, blue. So I've just softened them all down a bit, so we've got more pastel-y kind of colors. So if we run this, you can see the difference now. There we go. We've not got the text in nicer colors. So what I want to do here is I want to import Pygame CE, which is the latest community edition. It's got some extra features and runs a bit faster. So let's do that experimentally now. I think all we have to do is from the command line, we can just go Python pip install Pygame CE. Okay, it's doing something. No such option. Okay. Python. Let's it will stay with my command lines. Here we go. Okay, so it turns out we have to uninstall Python first and then reinstall. Uninstall Pygame first and then reinstall Pygame CE. So that's all done. So where were we? Creating a character. So this is my game class. These are my states. The scene. This is where we're going to put the character. In fact, here, when we're in the scene, we don't have to instantiate the splash screen and enter it. We can actually just go after exit state, and that will pop the state off the list, and it'll go back to the splash screen. So a little bit tidier. There we go. Exit state, same functionality when I press space. Close that. So we're going to create a new file. And we're going to call this characters.py. And then we're going to import Py. And from settings, import all. And actually, I want this to be modular, so I'm going to create a NPC class with some base statistics and physics and movement, so we can move that character around. And I'm going to make the player inherit from that class, and the player will have extra functionality, like a different input method, so it responds to our key presses, etc. So next from Pygame sprite. So I want to pass the game through here. I want to pass the scene into here, so anything in the scene I can call in here. Groups is going to be passed. Position and the name, so we can differentiate between the characters. So I want to inherit everything from the sprite class, so super for the init method. And so whatever sprite groups we pass in here, this will automatically be added to that. So I'm going to create an instance of game and the scene. and the name. For now, we're going to every sprite has an image and a rectangle assigned to it. So the image for now, we're just going to give it a standard Pygame surface of, say, tile size. In the X direction, tile size times 1.5, so 16, what would that be? 24. So it'd be 16 and 24 high, just to show a little extra height like a character would normally. On top of this, we now want the rectangle, and we can just say image.get frect we can use now. So frect is new to Pygame CE, and we can move rectangles with floating point numbers now, not just integers. So you don't have to round everything up before you move it. So image dot, and then the top left is going to equal the position we pass in here. So I'm going to give it a speed. Speed is going to be 60. So I've done this before, so you might have to play around with these. So that's the maximum sort of speed my character is going to go, and that's the force, is the input force. So what force is applied to the character, and as to how quickly it's going to start moving. And this speed is the limit of the maximum speed, because we're going to do it physics based. So based on that, we need an acceleration. So what we're going to do here, I've put this in here to make it easy. So instead of having to write pygame.math.vec every time, we can just import it as vec. And because this settings we've imported into here, then we can just say vec. So this is going to be a vector of 0, 0. So leave it blank and it will default to 0, 0. And then I want a velocity. Self velocity is going to be the same to begin with. And then we want a friction value. So self.friction. And this is going to be minus 15, which works quite well for me with these parameters. So let's give it a movement function. So pass dt in here. Let's pass for now. So it's there ready for us to put things in. And then dt. We'll pass on the update for now too. And then remember, we're going to need to create a player. We're going to inherit from this. So inherit from NPC. All the same. Let's take everything for the previous class. I want to put that in here. I want to inherit all these. Whatever's passed in here will be instantiated here. And same again here. So that should just give us a base player class based on the NPC. So when we go into our state, what we should be able to do is in our scene, we can instantiate the player in our instance, in our init method here. So we call it self.player in the scene. And then it's going to be an instance of the player. And let's check what parameters we needed. So we needed these parameters. So we've got the game, self.game. The scene is itself. So this is the class that we're in. So self, pass the self through there. Groups, we can put a list of groups in here. So what I want to do input sprites and then drawn sprites. Sorry, update sprites and then drawn sprites. And then we can update them respectively here and draw them respectively here just to keep it all tidy. So all my sprite groups I call something sprites because then I know it's going to be a group. I find that helpful for me. And that's going to be Pygame sprite group. We can copy that down. And I'm just going to put drawn sprites, so sprites that are drawn to the screen. The player we want to update every frame to what it's doing, moving, etc. And we also want it drawn every frame. So I'm going to put these into here. This list, update, and drawn sprites. Position of this player. For now, let's put them in the middle of the screen. Him, her, they. Width, height, divided by 2. Be slightly off center down to the right because remember this position, the player will be drawn with the top left in this position. So it'll be slightly down and to the right. Name is player. So this is just a string for now because I want to differentiate my different NPCs here. So it'll give it a different image, for example. So of course, we need to import the player. So from characters, import player class. Should show up as a black square. Well, black rectangle when we run it. Okay, we've got this one here. Just a little syntax error. Okay, so we've got another error. Indentation error. Why is that? So that's in our characters. Of course, here. We just didn't indent this properly. Is this? No, groups is not defined. I know why. So we're not even updating or drawing in the scene, are we? So the player's there, but it's not being updated or drawn. So obviously the player is in these two groups, drawn sprites and update. So if we just update here, so I think we can get rid of this for now. We don't need to go back to the splash screen yet. Once we're in the scene, the game will be started and we can play it. So let's just go self.update sprites, .update, the pass DT in, and that should update all the sprites in this group. And here we still want to fill the screen with red, but we want to draw the player on the top. So we can just do self.drawn sprites, .draw. Let's send the screen from here. And then see what we've got. And there we go. We've got the player slightly to the right down from the center. It's black by default. Well, we can change that. There's no point at the minute because we're just playing with a rectangle, which is symbolic of the player. We can change it to an actual image later. So if you did want to do that, you could literally just go self.image.fill, just like we fill the screen. It's a surface, much the same as this image is a surface. And we can just call colors green, for example, and then it should be green. There we go. So we want to make the character move now. So we're going to start putting things into this physics function, and then we can pass the physics into the update for any NPC or any player that's in the scene. So our physics. So this is based on equations of motion, which is like high school, maybe A-level math. So you've got the forces, the velocity, and you just put these together in an equation, but in a code form. So acceleration is a vector, so we're going to do it in the x direction first. So acceleration x is equal to acceleration x plus self.velocity x times the friction, and then we take the self.velocity x, the acceleration x times dt to make it frame rate independent. And then so the center of the rectangle should equal plus by 2 dt. And we can put that function into here, pass in the dt, and then super means it inherits everything from NPC, so this should work for the player too. So, but nothing's changing yet because we're not adding a force to anything. So let's do that in the player class because it'll be specific to the player. So let's call it input. For let's call it movement. Oh. So remember we've got our dictionary of inputs, so we can just go if inputs left acceleration is equal to minus the force. So we're going to apply this force. That's going to be the acceleration. And if inputs right, to positive force. Otherwise, if we're not doing either of these, we want it to reset to 0. Then we could do the same in the up and down direction. But we haven't done it for the y-axis yet, only for the x. So let's try this. First, we need to add this into the update method of the player. We need to add physics AT. So this wouldn't naturally have the input method because, sorry, the movement method, because we've put it in here in the player class. So we've got to override the update method for the player, give it its own update method. We're going to put physics in there, and we're also going to put movement. And then it should do these as well. So now if we run the game, our left and right keys. Okay, we've got an issue. So for some reason it's starting over here, and it's not moving. So let's debug this. Acceleration X, position X. Of course, it's plus equal, it's not equal to. So let's just try putting this directly in here. We may not need the position variable. Let's take the position variable out. Okay, wonderful. So hopefully we can do the same in the open. So let's copy this. So this is the, annotate this. This is the Y direction. And then of course the inputs, we need to make them. So let's tidy this up. Let's put these directly here. Up, oh, down. Sorry, up, negative. So inputs down, we wanted positive direction. So it's a bit different to math in the Y. So positive is down, negative is up, but the X remains the same as math, where positive is right and negative is left. Okay, so got that's Y, so let's try this. And then use my cursor keys and we're going. So left and right seem fine. Up and down is good. But when I do left and up, go diagonal, it seems to move faster. So it's moving the same distance every frame when I press right. So it's also doing that when I move down. But diagonally, it should move a little bit slower. So we can easily figure in our physics method after the X and Y are complete. So if the magnitude, if the size of velocity vector is more than equal to, remember we set our max speed, then the velocity is equal to the velocity normalized, which will make it equal to each equal to 1 times the speed. So if the speed is 60, this will normalize the velocity in the x and the y direction, and then it will times by the speed. So if we run that, oh, normalized. Okay, it's because I'm English. I'm spelling it differently. Should be normalized. Do you mean normalize? I did, not normalized. And here we go. Now, before it was clearly going a bit faster than my 60 I'd set. So let's add some debugging text so we can see what's happening, so we can print out on the screen dynamically what's happening, the velocity, etc. So that's our player moving around, our cursor keys. Let's go to the scene and we can draw in some debugging text. So this is really handy to have while you're building your game. So we'll just create a small debug method, debugger. And so what I want to do is pass in a list of variables here, and then it can print them out for me. So So it might be a bit complex at first, but wrap your head around it as we're doing it. So I'm going to pass in a list to this. And with that list, we're going to enumerate through it so we get a number for each position, each item in the list. So for index name, and that's going to be the name of the variable, in enumerate to give our index for each item. List. I want to render text, so we've got a function for that. Self.game.render text. First, I want to put the name in. So the name will be what we've got in the list. So the list item will be a string. Color, I'm going to print it out from white on the screen, so it'll be in white text. The font. And then, so what position do I want it? Let's for now say 10 in the X direction, so 10 pixels across, and 15 down, seeing as just seems okay. So for this one, for each time we render this text, for each one in this list, we want to times by the index, the number. So number 2 would times 15 by 2, so it'd be 30 in the Y direction. And then when it goes through the numbers, the third one in the list, it would be 45, because it would be times by 3. And then, if you remember, it was centralized by default. So if I have them appearing in the top corner and centralized, if they're going to be about 10 pixels across, 15 down, they're just going to be all over the place and going off the left of the screen, and they're all going to be in line. I want them nicely lined up with the left-hand side. So if you remember, if we press false in here, it will just default to the top left. So each string output will be drawn on the screen nicely on the left-hand side and drawn from this position being the top left. So now we've got that, we can draw it. So we're going to draw it on top of the screen, but let's draw it on top of everything. It's only text. So self.debugger, and then we want to pass in our list. So let's just create a list. And then we can just start typing things in this list. So it needs to be a string. Firstly, I want to see what frame rate we're running at. So if I go string of FPS, put a space here, and then I want to add another string to this. So I want the FPS, so the game clock get FPS is a function we can use, but we don't want it with a massive long floating point number, so we want to round it. So if we go round self.game.clock and then get FPS, and then you pass the parameter in here of how many decimals to round it to. Let's just say 2 for now. And then that's one element in our list. So that should just work. And I've only put this and this here, just moved it down, so we can just, for example, add another element very easily below. So, but for now, let's see if this works. And there we are. So we're running at about fast frame rate, 700 or so. So that's as fast as the computer can do this. So I've got my screen capture recording. I'm only on a standard kind of 8 gig laptop. So that's pretty fast for Pygame. I think there's like a 2000 FPS limit I've heard for Pygame, but I don't think you're ever going to get your game to run that fast in Python. So let's got our debugger. So FPS, let's do that to make it neat, to show exactly what it is. So yeah, so I don't really want my game to run that fast, but because all the speed values in my character class are times by delta time, if I go back to my game, so we can actually put a desired FPS value in here. So let's actually make this an attribute. So self.fps, let's say 60. And in here, self.fps, let's call it none for now, make sure that works. So it's not going to pass anything in, so it's going to run it as fast as possible. It's not going to restrict the frame rate, it's just going to do it as fast as the PC can. So that should... No, must be a real number, not non-type. So yeah, pass 0 and it's fine. So there we are. So now let's pass in 60, make it 60. And it's hitting the screen 60 times a second. So there we go. It's probably much easier on the computer. And because it's frame rate independent, we get the same movement speed. So no matter what we do, yeah, we can do 30 FPS again. And you can still, it's a little bit jittery because it's only updating 30 times a second. But this will then run well on computers that maybe can't run it at your desired frame rate. So down to 30 might be better. And we can pass this DT throughout our game now. Rotates or has got a speed or something, we'll need this DT passing into it. And 60, we're going to stick with 60 for ours. If you do uncap it and leave it at 0, of how well your game is performing, because this is how fast a computer can physically run it. If you implement a new feature and then this drops, then you know you've took a performance hit. Some things it's going to drop a lot. Collisions, rendering a lot of tiles on the screen, images, etc., which we're going to go through later to optimize that. But for now, so this is as fast as it's going to get. It's only going to get slower as we add more on. So it's a good tool that I use just to check the performance of my game as I create it. And to optimize things, I can compare one way of doing it to another and see if this changes much. Yeah, I think that's everything for the basic player and character and movement physics. And in the next part, we'll look at animation. So we'll add images to the player instead of just a rectangle, and we'll get it animating. So I'll see you then.